Hey, what's up guys? This is Akshay from AS Learning, and today in this video we'll be seeing about what re-rankers are. Okay, so for understanding re-rankers you must know what RAG is. Okay, if you don't know RAG, I have added a video in the description. Please understand and check what RAG is, and only then you would understand what re-rankers are and how they fit into the architecture of RAG. Okay, now let's understand where re-rankers fit into the RAG pipeline. You have a question which is asked by the user. You have a document which is vectorized and which is chunked, vectorized, and stored into a vector DB. The ask query is being vectorized by the embedding model. It goes into the vector store using similarity search or MMR, retrieves us the best k number of documents. Okay, and once you get it, those things go as a context to the LLM into its context window, the query, the chunks, and the LLM has a system prompt set, and accordingly it answers the question. Okay, now which are the best embedding models available right now, and people heavily use because they are into OpenAI ecosystem, or they are into Google ecosystem, or some into AWS, they use Anthropic, so they prefer to go with the best embedding models which they have. Like OpenAI's best is text embedding 3 large. We must be having something of Google and Anthropic. Okay, now they do a pretty good job. Okay, but let's say if you want to have a double check, you want to have a double check on if the context being retrieved for the ask query, is it good or not. If not, let's just do one more round of how good the context is with the query. Okay, or sometimes you use an open source model. Okay, people, like, we have clients who are like, we don't want to pay for this huge cost of LM, so people go for open source versions for them. And open source versions, because they are open source, they are less effective than these proprietary ones, and hence you will see that the retrieve contexts are not as good for the ask query. And if you have some niche domain where a fine-tuned model is being used, or in such cases you will also see that the context being retrieved is not good. Or even sometimes what happens is, what people do is, with their embedding model, they try to retrieve the best 50-30 chunks, and then they use a re-ranker model on the top 50, top 30 to give me the top 5, top 3. So it is like using the best two models to give us the most appropriate context for the asked query. Okay, it is like doubling the strength. So in this various ways and this various 2-3 scenarios, you will see that re-rankers really add a value. There have been a lot of research papers where people have really studied that re-rankers do add a value, and the scores where these searches are being checked, they have seen there's an improvement. Okay, so okay, fine, they do add a value, and so now let's see where do they really add a value. um, you have a query, it got vectorized, and let's say it returned you 50 best chunks. You can have a re-ranker model there and tell it to retrieve me top 5, top 3, top 7, because you want to be cautious on the tokens which you are sending, because every query is costing you, right? So we have to be cautious on the tokens, and hence you want the top 3, top 5, and you also want the best results to come out. Okay, so in this way re-rankers do really add value. Okay, now here what we will be seeing would be, we would be seeing, I've taken a text file. Okay, and I'm using Fez as a vector DB. I'll be creating a vector DB using Fez, and we will be seeing the results of the top retrieve context for the ask query without using re-rankers, and then we'll be seeing some re-rankers which are provided by LangChain to us. Okay, so here I'm using LangChain framework, here Fez for vector DB, OpenAI, text splitters. Okay, done the installation. Here I'm loading the key. Here you have text loader, Fez, OpenAI embedding, recursive character text splitter. Here I'm loading a text file, creating a chunk size of 500. The overlap is kept at 50. I'm adding an extra uh, ID key in the metadata just for understanding the retrieval of the contexts for the asked question. Okay, I'm using text embedding 3 large, OpenAI's best embedding model, and here my k value is 7. My asked question is, tell me something about food and local cousin of the country. The the text file contains the Wikipedia page of India. Okay, I just copied the Wikipedia page of India, and here I'm getting the relevant query result. And here you can see that I asked about food and local cousin of the country, and you can see that cuisine main article India cuisine, then some Indian meal, sorted meat, Persian cooking technique, platter thali. So the contexts which we have got, the chunks which we have got in the contexts, they are relevant. Okay, and we can also see the IDs which we have got because we asked for seven chunks, so it has returned us 7 chunks. Okay, now we will see how to use a re-ranker here. Okay, so here I've been using Jena re-ranker. Okay, and here I've in second example I've used to show an example for cross encoder re-ranker. So here I'm using BG re-ranker base of BAAI. Okay, so in the first scenario we have Jena. Jena is a private company, they have their own key, and you can just use their key and take help of the contextual compression retriever of LangChain, and you can use just do an import of Jena re-rank from document compressor. The base retriever will be the same as above, and you are just adding a compressor part to it. Okay, so here the base retriever is our retriever here, fetched from doc indexed this one. Okay, and here we are adding our compressor to it. I'm asking it the same question, tell me something about the food and local cuisine of the country, and here we are getting the top 3 results. Okay, you can change the k value and get more results also. Okay, here you must be seeing that you are getting a relevance score. This relevance score is an indication of how relevant the chunk is with the query. Okay, and you can see the higher the relevance score, the better the chunk result with the query. And you can see these IDs which we have. You can see that these numbers were present here also when we got it from OpenAI. 248, it was the second best chunk returned by OpenAI. Here it is returning the first best chunk. Okay, then we have 252. 252 here I think is at 5th number, and 255 is here at 3rd number, and here it told that 252 is at 2nd and 255 is at 3rd number. Interestingly, I think there must be some check on the length, maybe, could be, and hence I think the first one got eliminated. Okay, and this is how you got those meaty chunks. Okay, similarly we can do now let's say if you don't want to use any key based re-rankers, like you have Jena, you have Kohar, and there are many others. Okay, but you want to use open source or some kind of a re-ranker based model which is available on Hugging Face. So in those cases you can use Hugging Face cross encoder, and you can import the cross encoder re-ranker. Cross encoders are very useful when it comes to re-rankers. Bi-encoders are very good if you want to do the first stage of retrieval. Okay, why bi-encoders are good there and cross encoders are good here? It is because of the way they are trained. Okay, you can read more about them, how bi-encoders and like what are the difference between bi-encoders and cross encoders, and yeah, you can read more about them, like what is the exact concept there. But in the use case of re-ranking, cross encoders are better. Okay, and when you are doing the first stage of retrieval, at that time bi-encoders are good. Now here I'm using Hugging Face cross encoder. The model name is BAI BG re-ranker base. Here I've kept the top end value as 3 using the same contextual compressor retriever, and here I'm getting the 3 best retrieve chunks. Here also you can see that you got 248 as the first one. Interestingly, 244 was the second best one and 252 was third best one. Okay. So in this way, if you want to use re-rankers in LangChain's ecosystem, you have to use contextual compressor retriever. You have to plug in that compressor with a base retriever, and then you can use any re-ranker. Okay. So here I have shown how to use a re-ranker from Hugging Face, and here we have a Jena re-ranker also. Similarly, you have lots of re-rankers. When it comes to re-rankers, Kohar is a very popular name if you want to do re-ranking, and in many research paper you will see Kohar, Colbert, and these things being used. Okay, Kohar, Colbert, linear weight, cross encoders. So these are different things how people have studied on how re-rankers really add value over the base vector research, and there's a lot there. Okay, and you can read about it, and they have found out that re-rankers do add a value. In many papers, Kohar is a leading when it comes to metrics and a very good re-ranker model also. I've heard about Kohar a lot. Okay. Similarly, if you want to check on other re-rankers, this is the one which we used in the example, cross-encoder re-ranker. You can use any re-ranker model from Hugging Face, just plug in there and you can use it. Then we have others like Dashscope. Dashscope is given by Alibaba. Then we have Infinity re-ranker. Then we have Rank LLM. Then we have Volk Engine re-ranker. This is by ByteDance. Okay. We have Voyage AI, and there's a lot. Okay. OpenVino. Okay. So in this way, this is how re-rankers are there. Do study more about, I'll say, how, like, what exactly is cross-encoder re-ranking, bi-encoder re-ranking, linear weight re-ranking. We have Colbert, Kohar, and how these re-rankers internally create a difference when it comes to picking out the best contexts for a asked question. There are parameters like speed, latency, hit rate, also checked when re-rankers are being compared, because you are adding an extra layer in the rack pipeline. So we don't want the latency to be high, we want the speed to be as fast as possible. Okay, so there's a lot in the re-ranking world, and yeah, so this is what I had in the re-rankers for today. We understood what re-rankers are, how they fit into rack pipeline via code. We saw the use case of two re-rankers. One is Jena re-ranker and the other one is BAAI's BGE re-ranker base, where you can use any re-ranker from Hugging Face, and you can use cross-encoder re-ranker and just plug it up. Okay, so this is what I had in this video, guys. Yeah, that's it, and stay tuned to AS for more such amazing tech stuff. Take care, peace out.